So now I'm going to talk a little bit about, this is probably what you're more, well, not more interested, this is probably coming back to the content, not the content, what the test looks like, how the test is specified. So this is probably things that you might be interested in to either tell your students or for you to have more an idea of what this entails. But if you look at your document, because I might go through it very fast because it gets quite technical. Well, not technical, but I want to get to the examples because the examples are probably more exciting. And so we've given you in your document, I think on page 3 and 5, tells you what AL and QL is and how the test sits together. So that information, if I'm going too fast, you will find it in there. So now my presentation is broken into 2 bits. First, I'm going to tell you a little bit about QL, what QL is, and then I'm going to give you some examples of how students are faring, and I'm also going to look at the data for QL. The NBT institutions, some institutions, it's compulsory to write the NBTs, like UCT, UP, and other institutions do not use the NBT results. So we always say, and Jeline always tells the students, you have to look at the university or the institution's requirements, because they have requirements. So not everybody, and that's also to answer the lady's question over there. She said, why are some students writing NBTs and some not? That's the reason, because some programs do not use the NBT, other programs do. UCT, it's compulsory, some institutions not. So students have to look at so now, like I said, I'm going to do 2. So I'm going to first talk about the QL and what how the test is specified, and then I'll look at some data and then some examples. Maybe if you turn it on. So what is QL? People always confuse it with mathematical literacy. It's very similar to mathematical literacy, if one wants to say it's the equivalent. But we at the NBT say that the quantitative literacy, this is our definition, is when students or people manage situations or solve problems in real disciplinary context or responding to quantitative information that requires knowledge or activation of thinking, and then being able to represent or present that either orally, graphically, or verbally. Orally is verbally. So this is what we say the definition of QL is. And so this is a really lovely example. Stats essay a few years ago. I think they must have appointed a statistician that wanted to make stats accessible to everybody, so they often have these really exciting graphs or tables that makes it relevant for people. So the CPIX is always very complicated, and we hate that because it means that inflation has gone up or gone down. So in 2015 they released this, and so they said where not to have your cake and eat it. So in June 2015, I happened to be in Bloemfontein doing the same presentation, and then I said it's actually cheaper for me to have my chocolate cake in the Western Cape than in the Free State. It was about 10 Rand more expensive. So this is a basic, very simple graph, but this is an example of a QL event or a QL example. And when you go to the shop, and some people, or you see there's, you're going to buy sugar, and there's a 500-gram sugar and a 1 kilogram sugar, and the 500 grams, not kilogram, it's big, 500-gram sugar is 10 Rand, and the 1 kilogram is 15 Rand. You have to easily make that connection, because those people in the shops, they trick your brain. If you don't think carefully, they really trick your brain. So that is what QL is, and what we say QL should be, it's math for every day, mathematics for every day. So it's not math that Pragashini does, but it's things that you need to use every day. And when you get your pay slip and you see the deductions, that's math. So it's everyday math. So this is just a simple example. And then why do we say QL is important? And even students that are studying tourism, that are studying education, you think, oh, they don't need mathematics. They do, because they get graphs and they need to interpret graphs. They need to interpret tables. So we are saying that if a person is quantitatively literate, they can make meaning from quantitative information that they get in an academic discipline. And so they are able to interpret graphs, charts, and quantitative concepts, meaning that they can make they can make sense and reason about numbers. So QL and mathematical literacy is important. So this, and then Lindstein, he said in 2014 that QL is a habit of mind. It should come naturally. It should be part of you, like brushing your teeth or some of the other habits that you have. So why do we say QL? We say it's the content is using quantitative information, and it's reasoning, be able to express quantitative information coherently, and then it's always in context, application in real life context. So the example of the sugar, but in classroom it will be related to their discipline. So if someone is sitting in geography, they need to interpret information in their geography class or psychology class. So the context will always change, but it's always within context, whereas mathematics, it's not always in context. It's pure maths. But Pragashini will tell you a little bit more about that. So this is what the construct is made of, or what we consider the QL construct. Then the test is specified in 3 levels. Firstly is the quantitative competencies that students need to answer the question. The second one, the mathematical and statistical ideas. What concept is being tested? Is it volume? Is it probability? Is it rate? And then the cognitive processes. So it's also answering your question about earlier, which we'll come to. So firstly, I'll just go through this. This is in your document, so I'll just go through this really quickly. So when we talk about vocabulary, we're talking about QL concepts like percentage change, decrease, volume, mass, those kind of things. And then representations of numbers and operations where the students know BODMAS, multiplication, division, absolute values, and relative values. And then also these acting interpreting refers to how students represent data, so they get graphs, tables, are they able to derive meaning from that? And then at the same time, they should also be able to compute. So we ask computation numbers, but most of the numbers in the QL test, you don't need a calculator because they're not allowed a calculator. So they should be able to say that 4,000 and 2,000, there's a difference of 2,000. It's not, oh, I need the calculator. So it's very easily divisible or added up. And then the test also asks reasoning and being able to describe quantitative relationships. So this is the first component that is needed for the QL. It's the competency areas. Then, so yeah, back to the cake example, just to show you how this is important. So comprehending, knowing, that students should be able to know what the meaning of this word means, how graphs are constructed. This just happened, the x-axis over here are the provinces, and this is the value. So, and we've just put the data label on it, so that students should be able to look at this and know how to express this. So these are the things, connections between representations, that when I was in the Free State, I knew not to buy a cake. It was expensive. And also know that the average for South Africa was 47. And if you happen to love cake, I'm not a big fan of cake, but do not go, well, must also say that was in June 2015. They haven't updated it recently. Now they're into water, so the statistician has been using water examples. So not have a cake in the Northern Cape. Now, if they had to do it in June 2017, this picture could have drastically changed. So this was probably just relevant for them. And so students need to know the math. So if I needed to ask them what is the difference between the Northern Cape and the Western Cape, they should be able to make the calculation. And then there's essential and non-essential information, depending on your question, because it might be that all of these things are relevant. And then we also look at higher order thinking that involves reasoning, interpreting, reflecting, and also evaluating. So, yeah, QL example. Okay, so these are the mathematical and statistical ideas that are also assessed, and this is the second component of specifying the test. And these are the subdomains that I'm going to show you some examples of. And we have 6 subdomains in QL. And the first one is testing quantity, numbers, and operations. So these are everyday things: absolute value, relative value, ratios, calculations, estimations. So this is what we assume that students should know. And then we have data representations where things are in information or in graphs or tables. So any data representation, whether it's a flow chart, a tabular form, or a table. And then also we have shape, dimension, and space, and this is where you have scale diagrams or measurements. I have an example as well. And then we have relationships where the students can see whether there's a pattern in the data, and representation of relationships. The one is bigger than the other one, smaller or double the size. And then we have change in rates, where they have to look at ratios, rates that are represented graphically. And then the last one is chance, uncertainty, and probability. Now, of course, some students might never need this, not all of this in their course. But, for instance, when we were at a design school or design institution, they need to know how to estimate the length of material, or they have to estimate if they're making a table or something. Everybody will need it, even tourism, education students. It's not that some disciplines will have no QL. Some disciplines might be QL heavy, others less so. But they will need it. And they might not need all these subdomains. I just wanted to show you an example just to break up the technical things. And so, this is an example, and sometimes students or teachers, I'm not criticizing anybody's teaching, that now that at the university they have a lot of blended learning and they're using a lot of technology in teaching. And I just happened to find this because for some reason other students find this particular concept very daunting. So this is looking at surface area, and it's literally like 15 seconds. So just using a visual technology aid so students can see that a cylinder is made of 2 circles and then the rectangle. And then they also color code it so students can see what's happening. And then you give them the formula. And the reason why I'm showing you this one is anybody can study the formula and recite the formula, but if they understand the concept that there are 2 circles and that there's 1 rectangular, they would understand that more. So when they're writing the formula, they would know, I knew what is the surface area for a circle, and that's 2 times, and then the rectangle. So that's just what I wanted to show you. So our test also looks at misconceptions. Not all the items in the test are about misconceptions, and Pragashni and Sanet will talk a little bit about that. But for instance, we could also test, because the test is multiple choice, so if we're asking a question, please calculate the surface area, and we have options, and we can see that students are making errors that are leading to misconceptions, which means that even though you ask them to calculate the surface area, they are giving you the volume, or they are choosing the volume, or they are choosing the area. So this is just another example when you are teaching these concepts to students, that this is your surface area, this is volume, it's in cubed, or in squared, or perimeter. It's just another method you can teach or help your students. And so even here, just this particular item, you can ask them. So students have to know the units of measure for surface area, and they have to be able to identify and distinguish, which I spoke about earlier about the specifying the QL test, and they should be able to derive meaning and reasoning and interpreting, knowing that it's a rectangle and circles. So we also test misconceptions. So now I'm getting, which is good, I'm getting into, I've got a few examples, but I might just speak about one example, or 5 minutes, I've been told. So maybe I'll just go to one example then. And so this example is a lack of understanding between absolute and relative quantities and the lack of proportional reasoning. So for instance, the question is, which country had the greatest number of people under the age of 15? So number or greatest number of children, so automatically students go there and they see there, Netherlands has got a bigger proportion and Russia has got a large proportion. But it means that you first have to look at this group of students, these ones, in order to get to your answer. So this is an example of a multi-step application. So they have to know the words, what does greatest number mean, what does proportion mean, that they have to go to under 15, that's the total population. So this looks like a very easy graph, and immediately students might answer a particular answer, but just looking at the information, but it's not that, it's more than just that, right? So this is just how the students have answered. So the students that answered Russia in the basic, there were 15 of them, and the C, the option that they chose, was 78, right, which was not right. And then for Netherlands, how many, the total writers, the ones that got it right, 76. So this is the kind of information that we want students. So it's critical reasoning. It's not just give me the answer. So these are some of the questions that we're asking in our tests. So students should be able to know what the graph means, know what total population is, know that that's a proportion, and even though the proportion is bigger, doesn't necessarily mean that the greatest number will come from there. And then another one, which is, I'll just go quickly, when we ask what is the increase expressed as a percentage change, so you know that some people will say it's the change as a percentage over the final, so they'll get 33%, but it's actually over the initial, which means it's 50%. So these are the students that are getting, so B is the correct answer, and how many students, this one are getting it correct in basic is 19, 38 of them are getting it wrong, and here 35% of all writers are getting it right, whereas 33, and these are the ones that are all getting it wrong. And we can see what misconception was tested there by just using different formulas. So yeah. Then I'm going to get to this, the last two slides, which I think is very important. So what are institutions or universities doing that do receive the QL results? So some institutions, because we are sitting with the gebakte pere, so some of the institutions are developing basic numeracy courses. Now UCT and some other institutions, they have for all first year students, and obviously every department or faculty uses it differently, but at UCT all students that were in the basic and lower intermediate, they have an intervention. So we have QL for humanities, QL for psychology, QL for law. All law students, irrespective of whether you were proficient, you have to do the QL test. So some institutions that do have the funding and do realize that there are problems with their students, they make that provision for them. Then there are other universities that don't have that provision, so then they integrate it into their curriculum. So that's the second part, where some institutions have embedded the development of QL within their discourse in psychology, so they know that students are struggling. Their courses, for instance, psychology is QL heavy, so they have lots of stats, they have lots of graphs in it, and most of the students that are going to study psychology come from math literacy. So they have I won't say a deficiency, but some of them are not good with math, so they build in that curriculum in their courses. You have a question? So this is my last slide, and this is practical tips to facilitate teaching and learning. Possibly for you, take it, leave it, I'm putting it there. So what I'm saying is ensure that learners understand concepts. Don't let them recite the formula. I know that they get given the formula in the exams, in the NSE, in all your tests. In the maths, they are given the formula. In QL, they are not given the formula. Sometimes they are, but not often. So, but if they understand the concept, they can easily derive the formula. Second one, do not teach to the test. You are not doing your kid a favor. You are doing them a disservice. And I know I'm not criticizing, but teachers generally teach to the test. They give students the scope, they tell them. Some lecturers at the university do that, others don't. You want them to actually know the concept. And then teach reasoning skills, not just formula, but what it actually means. Ask the students to integrate or to interrogate the data. What does it mean if the graph goes up? What does it mean if the graph goes down? What does it... Ask them to interrogate the data. Teach them reasoning skills, because that will really set them apart from their peers. And then also ensure that readers learn, understand, and interpret the meaning of data found in various forms. Now, the the NBTA QL and the math test are currently written in English and Afrikaans, because that's the medium of instruction at the universities. But the reality is that there are students whose first language is not English or Afrikaans. So that's why it's important that students read, learn, and understand the concepts. And then finally, I want to stress how important it is that QL skills need to be practiced repeatedly, but most importantly that they understand the concepts and not just recite the formula. And it's important that at a very young age, but even when they are at high school, that they know about numbers, they can reason about numbers, that they have number sense and they understand that. So if you have children, when you go to the school or to the shop, you can just explain to them certain things, because math, this kind of math is for life. It's not just for higher education and not just for school. It's literally for life. You're always faced with QL and you're always faced with mathematics, and a calculator is not always at hand. Thank you.